Hello, everyone. Welcome to 3D Native's webinar, How to Overcome the Supply Chain and Labor Crisis with 3D Printing. My name is Madeline Pryor, and I will be your moderator today. I am joined by my panelists, Valeria Tirelli from Aidro and Pierre-Victor Sabatier from Desktop Metal. Good afternoon to you both.
Good afternoon.
I will introduce myself and the panelists in a little bit before we get to that. And while people are just still trickling in, I want to take the opportunity to send you a quick poll first, just to let you know we will actually have other polls today at different points. So, helping with audience participation. You should see it right now on your screen. If you would just take the moment to answer, it's so that we can learn a little bit more about you and the audience that we have here today. I will keep that up while people start answering. If we could actually just move to the next slide. Actually, just so you know as well, this webinar is currently being recorded, and if you would like to be notified, it should be up at a later date. You can always contact us at 3D Natives to know when it will be up. So let's get started then on talking about this. Actually, I see that most people, well, I'll let you guys finish. Let's get into it. So as you can see on the screen, apart from the poll, you can also see the agenda for the next hour. So as you can imagine, this right now is the welcoming participant survey and introduction portion of the webinar, where I will be introducing you to our panelists, as well as giving you a little bit of context for this webinar today. And after that, we'll be moving straight into how you can use additive manufacturing to ease supply chain disruptions and additive manufacturing tools for metal and casings, as well as how to identify parts that could benefit from 3D printing production. To let you know, there will be a Q&A portion in the last 15 minutes of the webinar. We encourage you to participate. If you want to participate, you can actually do it in the Q&A section, which is at the bottom of your screen. Please do ask the questions there, because if you do, I am much more likely to see them and ask your question. And as I said, it will be 15 minutes at the end. And just because this is a good point, I think most of you have answered. So I'm going to end the poll. And I will just share the results quickly so you can see. So this is interesting. Actually, the most people here are from the 3D printing industry, possibly normal considering the topic. And then next up is manufacturing and other. But that is quite an interesting mix of people. So I'm very excited to welcome you all here today. If we could move to the next slide. So, as I said, now I will be introducing to your panelists. And as I mentioned previously, my name is Madeline Pryor. I am the English content specialist for 3D Natives, which is the largest online media platform on 3D printing. We're actually available in 5 languages currently, English, of course, but also Italian, French, Spanish, and German. We also have webinars in those languages if you're interested. I am the moderator of the panel and the Q&A. And now let's turn to our panelists. First up is Valeria Tirelli, who is the president and CEO of Aidro, a desktop metal company, which excels in introducing additive manufacturing into hydraulics. She enthusiastically manages the company founded by her father 40 years ago in 1982. And the company specializes, by the way, in design and production of mechanical components such as valves, manifolds, and hydraulic systems. It is, in fact, a pioneer in the production of these components using additive manufacturing, including binder jetting and laser powder bed fusions. Aidro offers innovative and custom solutions that leverage the benefits of AM, including lightweighting, assembly consolidation, and performance. And since 2021, it has been a part of Desktop Metal, bringing 3D metal printing to mass production for various applications in sectors like oil and gas, energy, aerospace, and fluid powder. Valeria promotes the adoption of AM and the sustainability of the technology, supporting the reduction of the carbon footprint in many of these sectors, and is a member of international groups for the definition of guidelines and standards for AM, and is committed to the diffusion of it, which you can also see in her participation in events and networking moments, including the Italian Association of Women in 3D Printing. Next up is...
That's an impressive presentation.
Yes, thank you very much. Next up is Pierre-Victor Sabatier, who oversees strategic projects at Desktop Metal for the Europe and MEA region, which includes partnerships with R&D centers and contract manufacturers, focus on additive manufacturing industrialization projects, and deep dive on some key vertical markets ready to adopt AM in a big way. He spent his whole career doing sales and business development, especially in new markets, first in the private equity sector, and then since 2012 in 3D printing. He joined Desktop Metal at the startup stage and has actively contributed to solutions fast adopted in Europe. And in case there happens to be someone today who does not know who Desktop Metal is, surprising, but you never know. This company was founded in Burlington, Massachusetts, all the way back in 2015. Since then, the company has seen an extraordinary amount of growth and is working on accelerating the transformation of manufacturing with an expansive portfolio of 3D printing solutions. It was selected as one of the world's most promising technology pioneers by the World Economic Forum and named MI Technology's review of 50 smartest companies and the 2021 winner of Fast Company's Innovation by Design Awards in Materials. So thank you really both for being here today. We have quite an impressive panel. And
thanks, Madeleine.
And then moving on, actually, let's get into the meat of the webinar itself with some context. Just moving on to the next slide, please. Great. I'm sure you have all heard as well about the supply chain and labor crises. It started, of course, with the pandemic back in 2019, but it is ongoing and is likely going to continue to be ongoing for a while. One of the technologies that is expected to help and has already been helping is AM, which is what we'll be getting into today. I just wanted to show you this diagram to show some of the reasons why supply chain has been disrupted. You can see, especially with the pandemic, already there were issues, but adding that in, you have shortages of durable goods, which leads to production shutdowns, labor shortages, component shortages, all of it leading to strained supply chains. Additive manufacturing is one of the key technologies being put forth to address this. In fact, it's so key that the Secretary General of the United Nations Conference on Trade and Development confirmed that Industry 4.0 technologies, including AM, have become increasingly important throughout the pandemic as a way to address this. And just the next slide. Of course, we'll talk more about the supply chain today, but I also wanted to bring attention to the labor shortage crisis, which is also happening. You've probably heard about it in the news. The Great Resignation is something that I think many of us have heard about, where people are quitting their jobs. It is a little over-exaggerated, but it is true that currently we are in a situation where there is significantly more demand for workers than there is supply. Actually, if you see this graph here, which is from the European Central Bank on the US, it calculates the labor market tightness, which is defined as the ratio of vacancies to unemployment. And actually, if you see starting from 2021, it sharply goes from a little more even to having significantly more vacancies than people who are unemployed. This is one of the things that AM and other technologies in Industry 4.0 is hoping to address. And with that, that is actually enough from me. I will put you in our capable hands of our panelists. Once again, I just do want to remind you that there is a Q&A section at the bottom of the screen. Please do ask your questions there. Our panelists will be answering them at the end, and we're really excited to hear all your questions. And with that, I will say, well, take it away.
Thank you very much, Madeleine. So, hi, everyone. Thanks for this introduction. I think to go straight to the point, you mentioned something really important. And, you said that the difficulties of the supply chain we saw in the past 3-4 years could last a bit longer. In fact, when you talk to the people working in the manufacturing world, they start to think that it could last forever, in fact. And many of them, I kept in mind someone who said, now normality is complexity. Normal is chaos. And, the smooth supply chain is just a chance. And this person said, you cannot build a business based on chance. So you need to adapt your work. You need to change. The world is changing, and we have to change also the way we work. So that's clearly something important to keep in mind. We will have other pandemic maybe, but we could have also other boats stuck somewhere in Panama or Suez. We could have, other wars and conflicts in the world. And we have something else coming and starting to impact us, which is the global warming. And of course, no one can escape this topic and no one can avoid this topic in the business. So maybe the first point I wanted to highlight is the fact that additive manufacturing or 3D printing is just one of the pillars of Industry 4.0. Industry 4.0, it's an evolution of the industry to adapt to this new world and to all the challenges we see right now. So we speak about cybersecurity, we speak about simulation, big data, and as a company now, even a small and medium business cannot escape or avoid the big data topic or cybersecurity, because everything is based on this cyber world today. No company can avoid additive manufacturing and at least understand what's going on and how additive manufacturing could leverage, could help this activity. So that's the first point. I think people in the companies need to understand that additive manufacturing is part of this new industry. The second point, as it's indicated on the slide, the fact that this new world is a bit of supply chain challenges, complexities, like again, geopolitics, sanitary issues, or just troubles like we saw in the past years. But it's also, we have also this sustainability topic coming more and more. It's less discussed on the manufacturing side of the economy. More and more people talk about it, but in fact, speaking about the product life and speaking about how to reduce the use of plastics, we're speaking about the obsolescence of products, speaking about the way you source your materials. Is it coming from a sustainable source? Is it responsible? That's something really important to keep in mind, and that's again where additive manufacturing can have a big impact. So if we go to the next slide, it's another high-level topic I wanted to highlight. Usually and I see today a lot of people are from this 3D printing industry, but we keep hearing that 3D printing is quite complex, is quite difficult to work with, it's quite confusing. And in a way, it's normal because it's still, you have a lot of innovations coming every quarters, every years. You have a lot of announcements, you have a lot of players. It's not a mature industry. And so it gives this impression that it's very complex. It's true also that the workflow around additive manufacturing is also less mature. Additive manufacturing, it's not just a printer, but it's everything around, and it needs to be included in the industrial workflow of the companies. But I wanted to highlight the fact that two things. First, we made a lot of progress in the past years, and I think more than what the people realize. We have examples of industries that have been completely changed due to additive manufacturing, and we are qualifying, and we will see that more and more materials, more and more applications. So first, I think the people underestimate the new possibilities of additive manufacturing. The second point, we overestimate the simplicity of traditional manufacturing. Just because we are used, we've used machining, milling, casting, forging for the past 50 years. So people are used to it, and so they think it's easy. But if you talk to a production manager somewhere in France or in the world, they will immediately explain that even with the new challenge of the supply chain, this world is not easy and it's more and more complex. And what is interesting to understand is that the way you produce products is directly linked to the supply chain, meaning right now we had centralized production, we had a lot of logistics, a lot of initial costs, but because everything was smooth, no one really cared about the complexity. But as soon as the circumstances are changing and you put one difficulty in the supply chain, then you realize the complexity of traditional manufacturing, and then you realize that you have to adapt. So I heard someone speaking about cost optimized products, which is the case. In the past years, we have optimized everything for the cost per part, for the cost of the product, but saying that it's not performance optimized or sustainably optimized, meaning we don't include a lot of things in the cost of the product. So that's something I wanted to highlight. And maybe if we go to the next slide, I want, in fact, I saw that many people are coming from additive manufacturing. I will not go into the traditional advantages of 3D printing. I just wanted to highlight a few points. 3D printing is attractive for engineers, for students, for young generation, just because it's digital, it's new, and it's coming to your point, Madeleine, on the labor crisis. Of course, we have less people working, but we have also, and we have seen that in Europe in the past 20 years, we have too many people who, the industry was not so attractive. People were not attracted by going to work on a foundry, going to work on a CNC machine. And thanks to this digital approach of 3D printing, additive manufacturing, even if it's becoming industrial, it's attractive for the people, so it can solve one big issue in this one. The other point, and again, you can see that on the slides, we are back to something which is much more flexible, which is more decentralized, which is can be reactive to new changes. So that's something important to keep in mind. If we go to the next slide. So here it's just to give some examples. The first one, I wanted to highlight the fact that it's proven now. It's not a guess, it's not a bet that additive manufacturing will change the supply chain and the way we produce products. We have studies everywhere. It's just one of it here that you can see. Another example, maybe people have seen Gartner company. It's a big consultancy company. They have known a huge growth in the past 2-3 years just because they focus on Industry 4.0 and supply chain disruption. And surprise, they include additive manufacturing as a key pillar for their activity. If we go to the next slide, it's another example. I won't come back to, it's not surprising that the US are promoting additive manufacturing. It's not the first time, but I wanted to highlight it's the first time that it's really linked to supply chain. The US suffered from the supply chain in the past years, and they clearly identified additive manufacturing as one solution, and they bring massive investment on that. Next slide. Also, I think we have other examples. So in a way, it's not a good news, but for the industry, for additive manufacturing, the past years have revealed in a way what we were thinking and explaining in the past 10 years, meaning additive manufacturing, again, is super flexible and can bring a lot of advantages. So you can see a lot of the people attending today must be familiar with what happened with the COVID-19 and the pandemic. Many products have been produced by 3D printing during this time. And it was just a crisis, but since then, many companies are still using additive manufacturing. General Motors had big troubles to deliver its cars. And when you are a supplier of cars or 3D printers or whatever hardware or physical equipment, if you cannot deliver your product, you don't make revenue. General Motors was forced to find service providers using additive manufacturing to be able to finalize their cars and deliver the cars to the market. The same in Germany. We have one example with the Dutch Bahn. They needed to repair many trains, and doing that in 2 or 3 weeks instead of 2 or 3 months made a big difference for them. So I think step by step, the examples are bringing proof to what was explained to the market. So that's if we go back to this slide, that's the first level of the presentation I wanted to bring, speaking about the change in the world and the fact that yes, additive manufacturing is still early stage. Many things are happening. It's still a bit confusing, but it's the maturity is coming much faster than what majority of people can see, and in a way that's where Desktop Metal Group can change the game, and it's really something important. If we go to the next slide. Desktop Metal, now, as you said, Madeleine, I joined Desktop Metal on a startup mode. In the past years, we had, and especially last year, we had a very strong organic growth, but we did also 12 acquisitions in 1 year. Of course, small ones, big ones, but 12 acquisitions in 1 year. And thanks to that, now we are a very special player in this industry. So I think, I will explain a bit the difference of Desktop Metal. I think, Madeleine, you wanted to share, to launch the second question of the poll.
Yes, actually, this is the perfect timing. We're just going to launch one more question, same thing as before. You'll leave up and just to answer quickly. Well, you can keep going, Pierre-Victor.
Yeah, so what I wanted to highlight is first, there's no other player in additive manufacturing where you can find platforms and industrial platforms covering metal, ceramic, polymers, elastomers, sand casting, wood. So that's something, and the same, everything under the same roof, and everything based on what we call additive manufacturing 2.0, meaning industrial solutions. The second point, our platforms are based on technologies that can be used for volume productions. Since the beginning, it's a key focus for us. Our platforms are able to produce thousands of parts per week, and because we use technologies that are meant to be production technologies. And the last point, we have teams internally now, because we grew fast in the past months and years. We have teams here to help the industry, the players, the customers, to not choose just one technology or one printer, but just find the right way to adopt and implement additive manufacturing the right way, and benefit from the real value added of those solutions. So it means at the end, for all the end users, one thing important: instead of for you having to choose a technology, for you having to choose a product or a supplier, the goal for you is just now to focus on your needs, your applications, and we at Desktop Metal have sales, pre-sales team, experts, engineers able to recommend the best solution. We even have special teams, like for example our future market business unit, who can develop a solution when it's not on the shelf, but it's important for the customer. For example, titanium, aluminum, it's not on the shelf, it's not available for anybody, but we have a few industrial partners already qualifying aluminum and titanium parts for their business, thanks to the future market team. And last point, we have also a network of service providers that we work very closely with them. And if a customer comes to us and looks for a solution that we don't have in our product portfolio, we can still, because we understand that there's not a perfect solution for each need, we can still drive the customers and the partners to our service provider network, and for example use DMLS or LPBF solutions when it's the best one for the customer. So we can go to the next slide. So this slide is just an illustration of what I explained based on the metal activity, because now we do metal, but also polymers and other materials. But if we have a look at this product portfolio, it's really unique on the market, from We have solutions to produce a few parts per week to millions of parts per year. We have solutions that are completely turnkey, meaning easy to use and all included. And we have also open platforms that are completely open in terms of parameters, materials, and peripherals. You can adapt and choose on the market your peripherals and accessories. And again, it's something unique today, and we have the same for polymers and other and sand materials. Next slide. We have also, and I use this slide just to show that we are not only investing in 3D printing platforms and the process in itself, but we are also investing in the full workflow, and we have a partnership, for example, with a company named Lumafield, who is disrupting in a way the CT scan activity, which is a key element of the workflow when you go to real manufacturing. So it's just an example. And if we continue on the next slide. So I wanted to use this slide just to show that if you try to forget that you have to choose one technology or one supplier, then the goal is really to analyze your needs and to focus on material properties, quantities, and the value of the parts. So let's go quickly on some examples. For example, here you can see I wanted to remind to people that at Desktop Metal, all our metal solutions are based on what we call MIM-based solutions or sinter-based solutions, which means we 3D print and then we sinter. And this is important if we go to the next slide, because it brings several advantages. The first one is that we will use in our systems materials that are already qualified and benefiting for a huge period of experience. The metal injection molding world has developed, qualified, validated, and optimized the material science for them for the past 50 years, and now we can benefit from it. On the next slide, you will see also that many tests have been done, and sometimes many people don't know that it exists, but we have done some tests to compare, the properties of our parts compared to casting, for example, or machining or forging. And on the next slide, you will see also that we do a lot of tests to show that with our metal parts, you can do the same thing as on a CNC part, meaning you can mill the part, you can weld the part, you can apply heat treatment, post-treatment, finishing solutions. On the next slide, you will see another key point. Not only we benefit from the experience of this MIM industry and MIM materials, but we provide open platforms which allow us to use those MIM powders without having to customize it, at least for open platforms. And it's a big benefit, not only for the choice, we can propose a wide range of materials available on the market. We don't rely, or you don't rely on Desktop Metal for the sourcing for the supply of the powder. And the cost of those powders is obviously much lower thanks to the fact that it's not customized for systems. Another key point, when you work with this type of technologies, you don't waste powder because you reuse majority of the powder cycle by cycle. So if we continue, everything I explained is also valid for two other big activities at Desktop Metal. The first one is sand casting. So I will make it short. It's clear what we do today with digital casting, producing molds and cores in sand. It's what the foundries did for many years. We use the same we use the same sand, we use the same binders, and so foundries are used to it. And if we move on the next slides, you will see also but it's the same for the same reasoning, the same strategy on polymers and elastomers. We have open platforms. You will see it on the next slide. We have new generations of resins. We work with leaders in the market like Loctite from Henkel. And thanks to that, we have now materials enabling to propose end-use part production. And I think I've been a bit long. I wanted to share some examples. Annika, if you move to the next slide. But I think we have today the chance to have Aidro and Valeria Tirelli, who already validated many examples. So instead of showing the examples you can see on the screen, that examples that we can share with you all the time, we can make it available for you. We can show you dozens of examples of implementation of additive manufacturing for end-use parts production. But I think it's time to let Valeria present Aidro and how they implement additive manufacturing on their side.
Thank you, Vivi. So I'm very happy to be here and share my experience. So as you can see, Aidro is a 40 years old company. We started to work in conventional mechanics, especially in hydraulics. And now we added new activities, new technology with additive manufacturing. And this was really amazing for us because we started a new journey into innovation and with the possibility to create new products that are not possible with conventional manufacturing. And I'd like to start with this example. So in the next slide, you will see one of our conventional valve. This is a very typical hydraulics valve. But as all the other sector, we are facing a lot of challenges with the supply chain. So thanks to the fact that we have additive manufacturing department and we already have a know-how on how to design and produce parts with 3D printing, we are now able to solve our problem. And in the next slide, you will see the solution. So we started with the binder jetting system to produce the body valve. So this is a part of the valve that you have seen. Of course, we made a redesign for additive manufacturing, taking all the benefits that we have from this technology. And in the next slide, you will see exactly what I mean. So from the conventional parts, conventional body of the valve on your left, you will see that thanks to the redesign for additive manufacturing, we are able to have a very light component, 60% weight reduction, with also big space saving and the same function. So again, thanks to the ability that we have learned in the past years to design for additive, we are now able to solve our problems also for the conventional manufacturing. And in the next slide, you will see the complete valve with the body, 3D printed body. This part was made with the binder jetting, as I mentioned, in stainless steel. Just to give you an idea of the production, because hydraulics valves are a mass production. We are producing more than 50,000 parts per year. And thanks to additive manufacturing, and in particular with binder jetting, now we are able to think to replace the conventional manufacturing with this technology. In the simulation, you can see that with the shop system, that is, I say, the entry-level machine, we can produce roughly 8,000 parts per year. But with the bigger machine, we are now able to produce more than 200,000 parts. So a very, say, mass production of customized parts. In the next slide, you will see another example. This is a plug, an hydraulics plug. So it's a component that we install in our valves. And again, this year we were quite crazy to find these parts because there was, a lot of problems with the metal parts, with the supply chain. So at the end, we decided to solve again our problem and print these parts. In this case, we didn't make any redesign, so the part is as the conventional. But due to the fact that it's quite a small part, it's more or less 2 centimeters high, we are now able to produce a very large volume of parts. We are speaking of 40,000 parts with the conventional machines, so the shop system, and 400,000 parts with the big machine. So it's really a new possibilities that we have for mass production of parts that have also the same design as the conventional manufacturing. Of course, we also tested the mechanical properties, and we tested in our hydraulics test bench these parts, and the results are really amazing. So the component works exactly as the conventional ones. And in addition, in these parts, you can see the threads, and with binder jetting, we were able to print the threads. So there are no necessary post-processing on these parts, and this saves a lot of time and save a lot of post-processing work. So in the next slide, you will see a summary of the benefit that we found using additive manufacturing in hydraulics. That's our main market. So from faster time to market, less material consumption, because as you know, additive manufacturing adds material only where it is needed. And so we have less post-processing, meaning less CNC machining or other activities. We have a huge weight saving, the possibility to integrate multiple components into one, and other two benefits that I will explain you later. So digital inventory and sustainability. In particular, you see for the digital inventory is a huge project, and you will see an example coming in the next slide about what is really necessary to do for a digital inventory and to digitalize spare parts. This was a case study we made together with one of our customers for oil and gas valve. We started with the analysis of the inventory, so the actual physical inventory of parts. We identify which part can be digitalized, and then we produce a digital file, so the design for additive manufacturing. With the printer, we produce a few parts, then were tested and tested on functionality and on mechanical properties and non-destructive tests. And then you see these two components are two components for a big oil and gas valve were installed in the fields. So this is a very good example of what we can do with additive manufacturing to save the supply chain issue and to have a digital file instead of physical spare parts. But in the next slide, you will see that to do everything, it's really necessary to have a qualified process. So we started a few years ago also to implement our quality systems to include also additive manufacturing in the qualification process, starting from the raw material that now is powder, metal powder, then the printing of coupon, the testing of the design and the physical parts, and then we can reach a qualified parts that can be installed also in a critical application. And the last point that I like to share with you is about another benefit that I see. And in the next slide, you will see sustainability. This is a very nice aspect of additive manufacturing. As already mentioned, with additive manufacturing, we are able to reduce the material consumption, and it means also reduce the energy consumption to produce the parts. In the next slide, you will see an example of a study we have made together with CNH Industrial for an hydraulics manifold used for the agricultural machinery. You see in the middle the conventional manifolds. It's a very big part with a secondary manifold installed on the top. Thanks to the redesign with additive manufacturing, we were able to redesign the two components into one and to save 35% of weight. The part was printed, was tested for 1 million cycles resistances, and we also made some calculation on life cycle assessment to understand if with additive manufacturing, we are able also to save CO2 emission. And this calculation with some assumption, of course, show us the sustainability of additive, giving a result of 60% of CO2 equivalent reduction, emission reduction. This is a really impressive results. But I'd like to introduce also another points, because in this case, we just printed one prototypes because it's quite a big part. But what is possible also with another technology that is sand casting is to print the mold. And in this case, this could be a very good candidate for sand casting, because we will be able to save time, save materials, but also to produce large volume of big parts. So that's all from my side. I hope I share some good example and give some inspiration for new ideas with additive manufacturing.
Thanks, Valeria. Clearly, it's very valuable to have real examples, and we have, as I said, a lot to present coming from many customers in the world. But the way you implement additive manufacturing, taking into account your experience of 40 years of traditional manufacturing for some products is very interesting. And at the end, as you said, that's I always summarize the value added of additive manufacturing by saying, okay, at one point it's easier to save time, save money, or make money for the end users. And I think you gave different examples like that. Another point I wanted to highlight is the fact that not only we can improve performance, redesign, bring complexity in the parts, but sometimes, like the parts you showed with the thread, sometimes even the standard part that is done in traditional manufacturing, because the producer has other challenges like supply chain disruption, shortage, etc. Even standard parts that are traditionally used or produced by traditional manufacturing can be produced by additive manufacturing, and it makes sense, economical sense, or just business sense, because you need to have your parts quite fast. And so in a way, we are very happy to have a company like Aidro in Desktop Metal Group, because as I said, and that's where I wanted to conclude, the goal now for us is not anymore to just go to the market saying, okay, we need to sell this type of this product, this technology, this process. We want to change the approach, and we want the end users, the customers, the companies to come to us with their needs, their challenges, their pains, and their goals, and to work with them on how we can bring the benefits of additive manufacturing. And as you can see on the slide, for example, we have huge knowledge coming from thousands of users worldwide, helping us to better understand where we can propose solutions. And Aidro is just adding another valuable knowledge to that. Another key point is to keep in mind that we continue to invest massively in additive manufacturing R&D, and that's the only way to continue to become more mature and more industrial. As I said, we have solutions that are, we have turnkey solutions, very easy to use, very easy to operate and to install, but we have also fully open and scalable solutions to go to mid-volume and big volume production. And we have the widest product portfolio on the market, not only in terms of technologies, but in terms of materials. And sometimes one customer can come and say, okay, I need aluminum parts for this application. And the proposal from us will not be aluminum, but maybe redesign parts on stainless steel, or even maybe a wood part that can be used as a jigs or fixture. So I think at Desktop Metal we try to stay very open-minded. We use now all the assets we have in what we call Team DM, the Desktop Metal Group. And the last point I want to highlight is the fact that now, even if we are a US company, now with the growth and the acquisitions, we have very strong teams in Europe. We have our new headquarters, let's say, in Germany, with thanks to the acquisition of X1. We are more than 200 people in Europe, being able to support any customer project. We have dedicated team like pre-sales engineers and future market team. And we want also to leverage our ecosystem with resellers, service providers, and R&D centers that are also investigating a lot our solutions. So that's what we wanted to share, and we hope it was useful and clear for everyone. But we succeeded to be on time to leave a room for Q&A.
Indeed, and actually, just before we get to the Q&A, we do have one last question, which I am launching now. You should be able to just take a look and answer. We can do it as we're doing the Q&A. I see we have quite a few already. Feel free to put more in. If we don't get to all the questions in this 15 minutes, well, the contact information is up on the screen, so you can contact either Pierre-Victor or Valeria to get some more information. And also, just so you know, you can upvote the questions that you find the most interesting as well, so that way we can see what are some of the most, well, exciting questions. And actually the most popular one, I think I do need to give a little bit of context to. For those of you who didn't see, Valeria actually answered a question on the benefit of 3D printing for supply chains. As she answered it manually, you can see it in the Q&A box. Just to start explaining that companies need some time to understand the benefits of 3D printing, to verify the feasibility of production and its reliability, among other things. I've said you can see it, but there was a follow-up question for that actually, which is from Len, and explaining which says, what in your view, well, Valeria, should 3D printing firms, including OEMs and service providers, do differently or more, or stop doing to accelerate the awareness of 3D printing and therefore adoption?
In my experience, I think the best is to show the case or real parts that were 3D printed and have success in the fields. I'm also working in a lot of groups to promote the technology and to help people to understand the benefits. For example, there is AM Energy. It's a group working specific on energy sector, or I'm also helping women in 3D printing. So another association helping the people to share experience and support each other. So I think one of the best solution could be share as much as we can the successful story of 3D printed parts.
Indeed, that is the way about it. I do agree with you there. Well, I will actually ask then the next most popular question. Feel free, either one of you, to answer. How is actually the supply chain and labor crisis affecting subtractive manufacturing and CNC?
Yes, I can reply exactly also from my experience, because from the hydraulics department, we are still using, say, subtractive manufacturing. And what we faced in the last year or last month was a very difficulties to find the parts. The cost of the raw material was, jumping high, and then now a little low. And especially the suppliers, they have very long delivery times. So we are really facing some crisis in the conventional manufacturing in general. And also the people, probably after COVID, there were less people working on certain activities. So I see that additive manufacturing could be a real solution to replace parts made in conventional manufacturing, and to accelerate the creation of new parts and the time to market of the product.
Okay, thank you. Well, we'll continue moving on. I think this question is also possibly for Valeria, though Pierre-Victor, at any point, feel free if you want to add on to any answer as well, which is, how does the cost of an AM valve compare to a conventionally manufactured valve? Conventionally, sorry.
Yes, I know this question is coming very, very often. Again, I can tell you it depends. It depends on the size of the valve, on the complexity, and the technology used to produce the valve. In general, we see that It depends if we are speaking small volume or big production volume. In some cases, 3D printing is more expensive, so I can say the truth. Sometimes, if we are able to use the design for additive and, for example, to integrate multiple components into one, or we can save weight and space. In this case, we add value to the parts. So we cannot compare the conventional, say, easy parts with the 3D printed complex and high value parts. So again, there is an official rules between the cost of the conventional parts and the 3D printed parts.
Great. Thank you.
Maybe Madeleine, I see there's a lot of questions around the digital libraries, digital inventories. Just to add one comment, I think, as I said, it's really a matter of workflow, meaning it's not only a 3D printer who can solve this topic or improve this topic. This 3D printer is just one tool in the workflow. And that's why I wanted to mention the CT scan partnership we have, because it's another piece of the puzzle for that. But clearly, the software solutions that are provided today are a key piece of the workflow, and we can give some examples like 3D Spark, spare parts 3D. We have Vistory, for example, with the M-Chain. Those companies are really helping the customers to digitalize their spare parts, for example, inventory. Database, and then screen those bays and those parts and analyze which part could be produced in which technology with which material, which part would make sense, taking into account initially the cost per part, but now more and more we add also the complexities around the cost per part, meaning logistics, sustainability, carbon footprint. So those software are a key piece of the workflow, and the goal for Desktop Metal is to partner with those companies to first make sure that you can check the Desktop Metal equipment on those platforms, but also make sure that you can find afterwards a service provider, a production capacity somewhere in the world answering your needs.
Great. Yeah, it's true. Well, you have a lot of components that come together with AM, all of which are important, and actually kind of expanding since we discussed just if you could elaborate, one or both of you, on some of the specifications of a digital library as well, and some of the other examples, if you have them. Obviously, we've gone over one, but anything else? No.
I don't know, Valeria, do you have examples of
I know there are a lot of, I say, projects in different sectors working on digital inventory, like, for example, in energy sector, but also in mobile machine sectors. So the majority of big producer and big OEM are thinking now to transform the physical inventory into a digital inventory, especially for the sector where they have to guarantee spare parts for at least 20-25 years. It's not easy. It's a very big plan. We are supporting some of these companies, and I say the main starting point is to understand the technology, so additive manufacturing technologies, and which of the different technology could be suitable to produce the spare parts, depending of course of the material, if we are speaking metal or polymers, first of all. And if we are speaking about metals, normally are also critical parts. So it's also necessary to have a qualification journey before to say it's possible to 3D print the spare parts for a critical sector. But we see a very important trend on digital inventory. So my suggestion is don't stop to think about this, because in a few years we will see more and more files instead of physical parts in all the sector where we are living.
And maybe to complement, to explain a bit on Desktop Metal side, on the equipment supplier, what we can play as a role on this initiative. I think we can highlight 3 points. The first one, we are working actively to make to connect our equipment to all the softwares and digital platforms, so that, you know, like Industry 4.0 compliance, that's very important, so that then our systems are included in the industrial workflow. The second one, we help the end users to, on the design side, with design guidelines, with trainings, with on-site workshops to help them identify the right parts, the right candidates, and which are not the right ones. For example, we can spend 1 or 2 days at a customer site working in the warehouse and checking the parts and giving some examples, helping the people on site to do this exercise. And the third point is also helping to build a real comprehensive cost model, because usually and very often in the additive manufacturing industry, we were focused on the consumable cost or the hardware cost. But of course, running an equipment, it's paying for people, paying a facility, having electricity and gas, which is not something you know, not important today. And so we have developed specific knowledge and specific tools to have a very comprehensive cost models, and we can share that with and work on it with end users.
Sorry, muted. Yeah, indeed, I fully agree, and it's an important point to think about. I think we can probably get in 1 or 2 questions, depending. The next one, an anonymous attendee asks, we mentioned mass manufacturing. What about distributed manufacturing, reduction of inventories, etc.?
Yes, exactly. This is a part of the digital inventory plan. And the idea is to, for example, create the digital file in, I don't know, in Italy, for example, and then send the file to the 3D printer based, for example, in South Africa, and print locally the spare part that is needed. This is, again, is a big plan. It will require some time, but with easy parts and easy materials, I think we can start also today, at least start to create a local department with 3D printer in a different part of the world where there is also a critical you know, transport cost or issue in handling parts in some parts of the world where there are the plants of the end users.
And we are back to you know, defining where is the value for the end users. If the value is to lower the cost per part on big volume, then you need mass production tools like our production system, because you need to be able to produce millions of parts per year. Sometimes the value is in the, you know, the local production and the flexibility and the sustainability, the saving in carbon footprint. And that's where, you know, small systems and maybe slower systems that were not as attractive as our production system, for example, for the market. But those solutions are very valuable for the end users when you want to put a printer in each warehouse and in each site. Especially, we have a lot of projects with where we need to put systems in Africa, in Middle East, in Eastern Europe. And it's better to put turnkey solutions, easy to use and not so big, rather than putting 10 production systems in one site in the US. So again, it depends on the case.
Great. And then actually, I just have one question, which is, do you guys have time for just one last question, or shall we end it here?
I have time.
Let's go.
Let's go. Last question. And then there's a couple of others, but as a reminder, you have the contact information on the screen. Do feel free to reach out to Valeria or Pierre-Victor if you have some questions that were not answered in this webinar, or if you were too shy to ask them. So just the last question, which I think is a good one to finish out, is an anonymous attendee again asks, what would you say are some of the most important characteristics for a part that would be made using 3D printing? What kind of parts would be the most successful?
Again, I can share my experience. Normally, the parts that can have most successful are I say, parts that have some problems of supply chain, of complexity or weight. And additive manufacturing is a solution to solve this problem. I just give you this example. Maybe you can see this small plug. That was one of my example. This is very simple with not a lot of complexity in the design, but we had a lot of problems with our suppliers. So in this case, 3D printing saved time for the supply chain. And we were able, of course, to produce the parts in-house and install the parts in the final valves. In the case of this is the, you can see, I hope you can see, this is the valve, the hydraulic valve. In this case, we not only made the parts, but we also redesigned the parts, saving weight and space. So in this case, we are able to produce our final valves for special application where the weight is a critical issue. So I say there is no rules, it depends on the part, but just think what are the problem of your parts and why you want to use 3D printing.
Pierre-Victor?
No, that's a perfect answer. We are here to solve problems on the parts or on the supply chain around the parts. Also, we sometimes also to improve, and that's what is already known in additive manufacturing, but to bring innovations, to bring performance. But that's more known and understood in the market. But right now, the idea is to say each time you have a pain, or maybe you can anticipate that you could have a pain if something happened in the world. You know, that's where additive manufacturing is interesting. And maybe to conclude, I would say let's not wait for. I would suggest that the end users don't wait to have some problems to come to us, and because you have also a learning curve to anticipate. In any traditional manufacturing, you have it. It's true also for additive manufacturing. So the more you anticipate, the more you get used to design for additive manufacturing, to digital inventories, the better you will be prepared for this new world that is coming and already there.
Whether we like it or not. Well, with that, I will say thank you, well, especially to you, Pierre-Victor and Valeria, for being here with us today. Thank you, everyone, for attending. Again, if you have other questions, don't hesitate to contact them. They will be very happy to answer. The replay should be up in the next few days. Feel free to subscribe if you would like to get more information. And I will bid you all, depending on your time zone, good afternoon, good morning, good day, good night, and see you in our next webinar. Thank you.